Hello Precalculus students, and welcome to a video on the first of 3 videos on simplifying trig expressions. Now these are going to be fun because basically we're going to take things that are longer and make them into things that are shorter. We're just going to simplify, and we're going to use the identities that we talked about in the last video. And there's a bunch of stuff here, but this is starts out here with the fundamental identity. So they go from here to here, and we'll be referring to this for every problem. Okay, so the first problem, and this first strategy is actually to change everything from whatever it is in to sine and cosine. So if we look at the cotangent and the cosecant, based on our definition of the cotangent, or actually identity with the cotangent right here, we can rewrite the cotangent as the cosine over the sine, and the same thing with the denominator of the cosecant. We can rewrite that. So we can rewrite this as the cosine of theta over the sine of theta. There's our cotangent. Over 1 over the sine of theta. There's our cosecant. Okay, and I'm just going to rewrite this flip and multiply. So I have cosine of theta over sine of theta times the reciprocal of 1 over sine theta, which is sine theta over 1. Cancel with numerator and denominator, and we just get cosine of theta. Okay, so this is basically the process for the whole set of notes here. Is we're going to take something that's longer and more complicated, and we're going to see that actually this is the same as just the cosine of theta. Okay, let's look at the next example. So we are going to break both the cosecant and the tangent down into its pieces of sines and cosines. So the cosecant is 1 over the sine. So this is 1 over the sine of theta. The tangent is the sine over the cosine. So sine theta over cosine theta. And we are multiplying when there's nothing there. It's just implied multiplication. And so we can cancel our our sines, and we just get 1 over the cosine. Now you might think we're done, but we're not done, because 1 over the cosine is just, there it is, just the secant. So the easiest way of saying 1 over the, of simplifying this, the most simple form would be to say it's just the secant of theta. Now notice that these are both monomials. In other words, there's nothing being added or subtracted, and pretty much all of our answers in the end will end up being monomials. Okay, so the next example is going to also require us to break things down into sine and cosine, but first I just want to show you how to apply the even-odd identities. So remember, the only functions that are odd are the only functions that are even are the cosine is even and its reciprocal, which is the secant. So the only one of these is even, is the cosine. These are both odd. So when there's an odd function, remember, for example, that the sine of negative theta is the opposite of the sine of theta. Sometimes we think of that as just pulling the negative from the inside to the outside. And again, that is on our identity list. It's right here. The sine of theta is one of the odd functions right there. Okay, so we're just applying that identity right now. So that means that this first part of this long expression becomes the opposite of the sine of theta. The cosecant is also odd, so we can multiply and pull the negative out there. So this is the opposite of the cosecant, of theta. And the cosine is even, which means for the cosine, what we're really going to get here is just dropping the negative. The cosine of negative theta is the same thing as the cosine of positive theta. So we just drop the negative. So this is the cosine of theta. A negative times a negative is a positive, so this just turns into positive here. And let's write them in terms of sine and cosine. So we have the sine is already in terms of sine and cosine, so we have the sine of theta. We have 1, this is 1 over the sine of theta, so times 1 over sine of theta. And this is times the cosine of theta. you might see where this is going. The sine of theta cancels, and we just end up with this whole thing is really just cosine of theta. So that whole mess that we started with is really just the cosine of theta. Okay, why don't you guys try example 4. I'm going to pause the video and see if you guys can do pretty much the same thing that we just did. Okay, so let's see, did you guys get this far? First of all, did you note that two of the pieces again are odd, so there's two negative signs. Here I wrote it down, I didn't last time, but a negative times a negative equals a positive. That's why these both cancel away. Oops, both cancel away into positive, so there's no negative signs in our final answer. And we broke the cotangent down. This is breaking down the secant, and this is breaking down the cosecant. So the cosines cancel here, and we end up with 1 over sine squared. So this is 1 over the sine squared of theta. Well, we know that 1 over the sine of theta is the cosecant. So we really have the cosecant times itself. We don't normally have to write this, but the cosecant of theta times the cosecant of theta. And that's the cosecant squared of theta. And that's what we have here. So this is cosecant squared of theta. Again, just one term, nice and simple. All right, let's try the next one. So we have the tangent is an odd function. The secant is an even function. So when we rewrite, before we break it up into sines and cosines, we have negative tangent of theta. But the secant, being odd, is just drop the negative sign. So this over the secant of theta. So this time we are going to get a negative over a positive, which is a negative. So we're going to get a negative, and the tangent is the sine over the cosine. And then the secant is 1 over the cosine. And the cosines cancel. You can just do it this way, by the way. You don't have to flip it and multiply it as long as you have the same denominator. So we just get negative sine of theta over 1, or negative sine of theta. Okay, and the last example is using the Pythagorean identities. So let's look at this part right here, and we're going to be able to reduce this down because of the Pythagorean identities. So let's look at our identities and see which one has the cosecant in it. So of our 3 Pythagorean identities right here, only one of them has the cosecant in it. So I'm going to start out by just kind of writing that identity down, and you will see how it's going to reduce down. So cosecant squared is 1 plus cotangent squared. One plus the cotangent squared of theta. So when you get something like 1 minus cosecant squared of theta, you have to be thinking about the identity that has the cosecant squared to see if you can reduce it down. Now our goal is to see, is there a way, sometimes there is and sometimes there isn't, is there a way to rewrite this to make it look like 1 minus cosecant squared of theta? So I'm going to pause it, let you guys try to work that out. So here's just a little bit of algebraic manipulation of the identity that we know. And what I did was, you can see what I did here. Subtracted a couple things, moved them around a little bit, and we end up, there's what we really wanted. The 1 minus cosecant squared of theta is the same thing as the opposite of the cotangent squared of theta. So the first thing I'm going to do is replace this with the opposite of the cotangent of theta. So I have the sine squared of negative theta times negative cotangent squared of theta. Okay, now this sine squared, now we know that the sine is odd, and just another little side thought here, we know that the sine, we know that the sine, I'm on eraser, the sine of negative theta is equal to the opposite of the sine of theta. But when we square it, we have the sine, we're going to end up with the opposite of the sine of theta squared. and now that negative does square away. So it doesn't matter whether you're talking about an even or an odd function. When it's being squared, the negative will just go away. Okay, in other words, this is just the same thing as the sine squared of theta. So the sine squared of negative theta is the opposite of the sine of theta squared, which is the sine squared of theta. So this is sine squared theta, and the cotangent is cosine over sine. So this is going to be negative cosine squared theta over sine squared theta. Sine squareds cancel, and there we have negative cosine squared theta. Okay, hope you found this video helpful.